Welcome to the Unit 11 Section 1 video on solving quadratics by graphing. As we have previously learned, a quadratic function can be written in standard form, which is y equals ax squared plus bx plus c. Now, remember, a cannot be 0 because if a is 0, then we do not have a quadratic function. Likewise, a quadratic equation is an equation that can also be written as ax squared plus bx plus c equals 0, where a again cannot be 0. We say that equations like this have a degree of 2 since the greatest exponent of the variable is 2. Notice that a quadratic equation only has one variable and all the exponents are positive. The values of the variable that satisfy an equation are called roots or solutions of the equation. There are three possible outcomes when solving a quadratic equation. The equation will either have two real solutions, one real solution, or no real solutions. A graph of each of these outcomes is shown here. So here's a graph showing that the parabola crosses the x-axis 2 times. That gives us two x-intercepts, which are also called our roots or solutions, also referred to as our zeros. So we have two real solutions. In this parabola, only the vertex is touching the x-axis. In this case, we have one real solution. And then this parabola is above the x-axis and it is going infinitely upward. So it will never cross the x-axis, so there are no real solutions. Because the solutions occur where the parabola crosses or touches the x-axis, solutions are also called zeros or x-intercepts. We say that the quadratic function y equals ax squared plus bx plus c and the quadratic equation ax squared plus bx plus c equals 0 are related to each other. One way to solve a quadratic equation in standard form is to graph the related function and find the x values where y equals 0. In other words, find the zeros of the related function. So to solve a quadratic equation by graphing, you're going to write the related function, determine and graph the axis of symmetry, find and graph the vertex, determine and graph points on one side of the axis of symmetry, reflect the points across the axis of symmetry, and then find the zeros of the related function. So let's solve 2x squared minus 2 equals 0 by graphing the related function. First, find the axis of symmetry. We do that by using negative b over 2a since we are in standard form, and that gives us 0. Now we can take that 0 and plug it into our related equation, y equals 2x squared minus 2, to find the y value that goes with our axis of symmetry, and that gives us the vertex of 0, negative 2. Then we're going to take the related equation, and we are going to substitute two other x values in to get points. So for the first point, let's put in 1. Since our vertex is at 0, let's go on the right side of our vertex, or our axis of symmetry, and go to x equals 1, and get the point 1, 0, and move on to x equals 2, and get 2, 6. Okay, that should be positive 2, 6 there. And then we graph our two points on the right side and reflect them to the left side. And that's going to give us our x-intercepts, which are negative 1 and 1. So our roots are at x equals negative 1 and x equals 1. So our solutions are the set negative 1, 1. For this example, we are going to solve negative x squared minus 4x minus 4 equals 0 by graphing. So again, find the axis of symmetry by using negative b over 2a. Since we are in standard form, that's going to give us negative 2. Then plug negative 2 into the vertex, or into our related equation to find the vertex. And that's going to give us a vertex of negative 2, 0. Now let's do 2 points on one side of x equals negative 2. So let's go to negative 1 and find the point negative 1, negative 1. and we'll continue on to 0 and do 0, -4. So now, if we graph it by plotting our 2 points on the right side of our axis of symmetry and then reflect them across the left side and draw a parabola, you're going to find that we have 1 point on our x-axis. So we have a root of x equals -2. Since the vertex is on the x-axis, this has one solution. You can always solve a quadratic equation by graphing the related function. However, you may only be able to find approximations of the roots by graphing. That's the drawback here. You can use a graphing calculator to better approximate the value of solutions. So I'm going to take you through an example of how you can use your TI-84 to graph and find the solutions of a quadratic equation. So we're going to use a graphing calculator to approximate the zeros of f of x equals 2x squared minus x minus 5. And then we're going to round our answers to the nearest thousandth. So first you're going to want to enter the function into the y equals. So go to y equals at the top left-hand corner of your graphing calculator and enter in 2x squared minus x minus 5 into y1. So your screen should look like this. Next, we're going to go to the Calculate menu by pressing second trace. Okay? And your Calculate menu should come up here, and then we are going to go down to number 2, which is 0. And we are going to select that second item, 0, and it will bring us to this screen where you have the graph of your function, and you're going to have a cursor that's going to move along your function. And on the bottom, it's going to say left bound, and you're going to set those. And that's going to be in the next step. So you're going to use the left arrow key to move the cursor to the left of the intercept. So move it to the left of the left-hand intercept. So it will be above the x-axis here. And then you're going to hit enter. Then your menu on the bottom, or your prompt on the bottom, is going to ask for the right bound. So you're going to move the cursor to the right of the intercept, and you're going to press enter. And you'll notice at the top of your graph there, you're going to have 2 arrows that narrow down where your intercept is going to be located. It's somewhere between those 2 arrows that you set. Next, you're going to move the cursor close to the intercept, and then you're going to hit enter, and it will give you the value of your 0, or your x-intercept at the bottom. So you can see that your x-intercept is at -1.350781. We're going to round that to the nearest thousandth. So our first root is going to be at -1.351. Then you're going to follow the same steps to approximate the location of your other intercept. And you'll see at the bottom of the screen 1.8507811, which we will also round to the nearest thousandth. So you'll have x is approximately 1.851. I encourage you to go through this process with the following examples here, and I will show you the solutions so you can check yourself to see if you're doing it correctly in your calculator. So for the function 7x squared plus 4x minus 10, you should get approximations to nearest thousandth of -1.515 and 0.943 as your 2 roots. For the function -2x squared plus 6x plus 1, you should get -0.158 and 3.158. And for the function -3x squared minus 5x minus 1, you should get -1.434 and -0.232 as your x-intercepts or your solutions. Pause the video, keep these solutions up, and try it out for yourself on your TI-84. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.